Hello students, this side Preet Kamal. I'm a lecturer at Mahajal Polytechnic College, Jalandhar. Today I am here to discuss with you about the subject of computer networks. But before starting with the subject details, I would like to share an important information related to Mission Fateh, a campaign run by the Punjab government. It says that we should take some precautions like wash our hands regularly, use sanitizer, mask, and along with that maintain the social distancing rules so that we could come out of this pandemic situation of COVID-19 as early as possible, right? So let's move on to the subject details, and today's topic is TCP IP model. As in the previous lecture we have discussed about the OSI model, that is the open system interconnection model. Now in this lecture we will discuss about another model, that is a TCP IP model, that is an advanced version of, you can say, the OSI, the basic reference model. Some of the disadvantages that were incorporated in the OSI model that have been reduced in this TCP IP model, and that is why according to the new structure it has been made. No doubt OSI model was the reference model and it will be the reference model, but this is the advanced model that has some changes, as you can see here, that in this on my screen, that in this model, in spite of 7, we are having only 4 layers. That means the layers that were not so much of use and whose work could be combined, those are combined, and the work has been given to one particular layer, and that is why this kind of model has been designed. So let's move on and see how the OSI reference model has been converted to TCP IP conceptual layers or model. It is like the application, presentation, and the session layer. All these three layers, the functions of all these 3 layers have been combined into the application layer only in case of the TCP IP model. The transport layer is same, the network layer is same. It is, the name of the network layer has changed here. It is called the internet layer in the TCP IP model, and the data link and the physical layer, the function of both these layers have been combined, and it is called the network interface layer. So in this way, the TCP IP model has been designed that whoever layers were having very fraction of work, and it was not necessary to use a different layer for them, so they all are being combined, and their function has been performed by the single layer, right? So let's have a look on how the layers are working. The first one is the application layer that has the functions of presentation as well as the session layers. The functions will be same. The application layer will only be responsible for the functions of all the layers that we have discussed earlier in the OSI model. So the application layer, what it does is it will allow to assess the network resources. It will allow us, it will give us chance, it will permit us to assess the network resources. Whatever the resources we are using in the network, whether it's a PC, whether it's a the scanner, the printer, or anything that we are using in the network as a resource, it will have the function to allow us to assess all those network resources. Then after, other than that, all the applications, all the functions in the application layer are exactly same as there were in the your application, presentation, and session layers. Okay, so here I will add something, that the protocols that are used in case of application layer are telnet, SMTP, FTP, DNS, HTTP, and all these protocols are utilized. As you all know that telnet is your telephone network, then SMTP is your simple mail transfer protocol is there, then domain name services are there, then HTTP is your hypertext transfer protocol. All these protocols with whose help our system runs, our websites get opened up, and the way they are presented, all these things, all their small things that they perform, they are all done in case of the application layer. Then when we talk about the transport layer, then it is to provide the reliable process to process message delivery and error delivery, or we can say the error check possibility is there in the transport layer. It will allow the entities to move from the source to the destination, and it makes sure that it becomes a reliable process, that the signals could reach from the data could reach from the sender, from the source to the destination properly, appropriately, and with the maximum reliability. And along with that, the protocols used in case of in this layer are TCP and UDP. As we have already discussed, TCP is your transmission control protocol and UDP is the user datagram protocol. The TCP is connection oriented protocol, we have already discussed it, and UDP is connection less protocol. So TCP basically handles the flow control in this case, and it allows a byte stream transmitted from one machine to be delivered to the another machine, and without introducing any errors. It makes sure, the TCP protocol makes sure that there should not be any kind of errors. But the UDP protocol that is utilized sometimes in the transport layer, it is basically unreliable, it is connectionless, and whenever we don't want or some sequencing or some flow control, then UDP is utilized. But other than that, if we need an accurate delivery, if we need to have something we cannot afford to be changed on the path, and we cannot afford noises or any other things in between, then we use the TCP protocol. And whenever there is a prompt delivery needed, immediate delivery needed, then UDP is sometimes preferred over the TCP. Or it is used for sending the speech or the video signals. The UDP is used for sending the transmitting the speech or the video signals, and TCP could be used for the message signals. Okay, so this was about the transport layer, right? The TCP IP model, basically named as TCP transmission control protocol / IP is your internet protocol. So both the protocols are used in this case. So when we talk about the internet layer, then I could say that to move the packets, it is basically playing the role of the network layer that was used in the OSI model. So as the network layer was working, similarly the internet layer, only the name has been changed, otherwise the work is completely the same. To move the packets from the source to the destination, to provide internet working, then to insert packets into the network, fragmentation of the data that is being provided. Then the higher layers, they're supposed to arrange them in proper order, proper sequencing, right? So here the internet protocol is utilized for the proper delivery of the packets that are being sent to their destinations. Then the routing of the packets is basically controlled in this layer. Then the congestion control things are included, so that there should not be any kind of breakage in the signal that is being sent, right? The last one is the network interface. Network interface is basically, or sometimes it is called as host to network layer. Sometimes it is called as host to network layer, and sometimes it is called as a network interface layer, right? Both the names are being provided to this layer only, and this basically is responsible for the functioning of the physical as well as the data link layer. And as we all know that what is the function of the physical layer is to provide the link, to provide the physical link between the sender and the receiver. And what is the function of data link layer is to make frames, to control the error, to control the flow of the signal, flow of the data. So it is responsible for the transmission between the two devices on the same network. So both the functions, both the advantages of the layers of the physical layer and the data link layer, the functions performed by the responsibilities taken by both of those layers is basically performed here in the network interface layer. So we have reduced the layers so that the function, that means if I will give you an example, like for one thing, as I have given you this example already, some modification in the example, that if there are say 7 persons and we have provided them a few works, right, but we have another work also for them, so we will find out that who of those 7 persons, who is that particular person, or who are those persons who are doing some work which is under their capability, means less than their capability, whoever are working less than their capability, right? So what we will do, we will give their task to somebody else who is also having it having a less work, right? So we will give that task to that person, and we will free that person for some other work. So here also the meaning, the reason behind why we are changing those 7 layers to 4 layers, so that we could reduce in the layered structure, as we do not have so much work in case of presentation or session layers, and we could combine the data link and the physical layer, as they both are very much similar to each other. The frames and the bits and bytes, they are all very similar to each other, so we could combine all these things, right? So it will make the structure simpler, so that is why it is being utilized like this. So here it is being given an example, as I have given in the OSI model also. So here it has been shown that for example, here is an office PC from where the email is being sent, and here is another office PC where the email is being received. So how these layers of the TCP IP model will work for it, let's see. Say layer 4, first of all, when the email is to be sent, then what will happen is the application layer, it encodes the email and adds the header, that is SMTP. As I've already told you, that is simple mail transfer protocol. This protocol will be used to add the header to the email which is being encoded. Why it is to be encoded is because the email that we have written is in English language, the normal language that we could understand, but that language directly, it could not be a file, or the language or the file, it could not be sent directly in the particular form that it has been written. So for the machine, for this to travel from one place to another, it is to be converted, it is to be encoded, so that it could transfer, would move on from the one server to another, or from one PC to another, and that too with the help of the protocol. So the header has been added, the encoding has been done, then it is sent to the email server, and the server will add a pop and map IMAP header for the recipient to download, right? It will add up the things that the recipient could download, and at the other side the email is downloaded by the user accessed from the server. So here it is encoded and here it is downloaded, right? Then after the layer 3 transport layer, here the email encoded email is split into packets using the TCP, the transport layer. The TCP is utilized here, it breaks the encoded email into packets so that it could be transmitted as early as possible, right? So it tells that the recipient how many packets there will be, and the numbers of the packets are so that they are sent or delivered or put back together in the right order at the end. So the packets, whatever the fragmentation, that was the part that is being done in the transport layer. So in those packets, in those fragments, we include the sequence number, so that at the end, when those packets will be received, so they could be arranged in sequence and they could be received appropriately. So here it is split into packets, and here the packets are put back together in the right order. So in the internet layer, what happens next is it attaches the source IP and directs the packet to the destination IP. So the function of the internet layer is to provide the route, so that the packet should reach the proper destination where from for which it has been sent, right? So the internet layer, what it does is it attaches the sender's IP address to the packet and directs to and from the devices. This layer is done through routers. This thing is done through the routers or routers. With the help of the routers, what we do is we send those packets. In that packet, we are having the sender address also and the destination address also. So from where it has come and to which destination it has to go, accordingly the internet layer works, right? This is a function of the internet layer. And last one, it turns the packets into electrical signals or wireless or sends them to another device. The link layer or the network interface layer or the host to network layer, all the names are provided to this layer. So the data link and physical layer, both the functions of both have been combined in this layer. And what it does is, whatever the signals are coming in the form of packets or frames, what it does in this layer, all these packets, all the data that has been encoded, that has been converted into digital signals which is understandable by machine, now in this layer it has to be transmitted wired or wirelessly towards the second or next destination, right? So that is why here, because the wired signals or in the wireless communication, in both the types, we need electrical signals, as the digital signal could not be traveled in the wired or in a wireless system. So that is why what we have to do here is we have to convert those bits into the signals that are the electrical signals. So that is why this link layer is being utilized, and it has been transmitted to the next level in the form of electrical signal, right? So I hope this all is clear to you. The last thing about this is the TCP IP or the OSI model, the difference between the two, right? So when we talk about the difference between the two, we can say that TCP IP is the implementation of the OSI model. Obviously, as OSI model was the reference model, so in this, the OSI model has been implemented but in a modified way, right? This model around which internet is developed. So this is the practical model. TCP IP is basically the practical model around which the internet is being developed, and it is working right now. And in case of if we talk about the OSI model, then we would say here that the OSI model is a theoretical model. It has not been practically implemented. However, it is used as a reference model, but it has not been practically implemented. Next, the OSI model was having 7 layers, but TCP IP is having only 4 layers. So it is considered more reliable, but it is a reference tool. So practically, we use it very rarely. Okay. So in this case, in the TCP IP model, the protocols are strictly defined. They are properly defined. The protocols are strictly defined, and they have to be followed so that the proper reception of the signal of the data could occur, right? And then when we talk about the OSI model, so here we can say it's stricter boundaries for the protocol. So they are also having some boundaries, some stricter boundaries for the protocols. So beyond that, the protocols could not go. So this TCP IP model, it is having a horizontal approach, and the OSI model is having a vertical approach. Now, what do you mean by horizontal approach is that it could work like this: the application to application, transport to transport, internet to internet, link to link. But the OSI model has a vertical approach, that it can only go from up to down or down to up. Then in the case of TCP IP model, it combines the session and presentation layer and the application layer. As I have already told you, the functions of the session and presentation layer are being done by the application layer. But the OSI model has separate session and presentation layer. So all the layers, they will function according to them, right? Then the protocols were developed first, and then the model was developed. In the case of TCP IP, the protocols were first developed, and then after the model was made after the protocols, because the protocols were defined for the OSI model already, right? So the model was developed, first before the development of the protocols. In the OSI model, first the model was developed and then after the protocols were used in between. But before TCP/IP, the protocols were already in use, they were already developed, and then after this model was developed, right? So the TCP/IP model, it only supports the connection less communication in the network layer. In case of the network layer, if we talk about specifically, then we say that the network in the network layer only connection less communication is supported in the case of TCP/IP model. But in case of OSI model, we support the connection less as well as the connection oriented protocols, right? And this TCP/IP model is protocol dependent standard, but it is a standard and it is protocol independent standard, because the OSI model was developed first and the TCP/IP model was developed after the development of the protocol. So this was all about the TCP/IP model, the basic TCP/IP model, how it works, how the layers has been changed, what is the difference between the TCP/IP and the OSI model. So I hope it's all clear to you. If there will be any doubts, then we will be taking it in the live sessions. But before that, I would like to say that do not forget to like and comment on my video so that I could come to know that you have seen it completely till end. And subscribe this channel, and for more information we will talk in the live session. Thank you so much, students. Thank you so much for hearing. Thank you for your patience. Bye bye.